Hello everybody! Since Hkimo 2020 finals is coming, I decided to make tutorial videos again about Hkimo examinations or Hkimo tests. And today I am going to give you this practice test set A that I made for secondary 1 to secondary 3 levels. So this test is applicable to secondary 1, secondary 2, or secondary 3 levels. Some of the questions here also are applicable for primary 6 students. Alright, let's start with our first problem. Given A, B, and C are 3 non-zero digits and the 3-digit numbers formed by these 3 digits have the following properties. Number 1, BAC is divisible by 9. Number 2, ACB is divisible by 19. And number 3, ABC has an odd number of factors. So first, let's look at condition 1. BAC should be divisible by 9. Think of the 3-digit number which is divisible by 9. Okay, by constant practice, you will develop the skill already. And I'm thinking that BAC is 234 or 234. This is a 3-digit number which is divisible by 9. 234 is 26 times 9. Next, if I take ACB, that will be, my A is 3. Am I right? Yeah, 3. The C is 4. And the B is 2. Is 342 divisible by 19? Yes, it is. 342 is 19 times 18. So it also satisfies condition number 2. I think this is our correct set of numbers already. Now, ABC must be, what is our A again? 3. What is our B again? 2. And what is our C? 4. Should have an odd number of factors. So remember, to get the number of factors of an integer, you rewrite an integer into its prime factorization form. So 324 can be written as 4 times 4 times 81, and 4 is 2 squared. 81 is 3 raised to 4. Okay, so that is the prime factorization of 324. So to get the number of factors, we take the powers of the prime factors. Our powers are 2 and 4. Simply add 1 to each power and you multiply them together. So that power 2 plus 1 times that power 4 plus 1. So the total number of factors of 324 is 3 times 5 or 15. And 15 is an odd number, so it satisfies condition 3. The number ABC, which is 324, has 15 factors or odd number of factors. So all the 3 conditions are satisfied. So this is our correct set of numbers. Now, for your final answer, write CBA. Therefore, CBA is equal to, what is our C? 4, our B 2, and our A 3. So the final answer is 423. So that is our 3-digit number CBA, 423. Okay, let's go to problem number 2. Okay, problem 2. Given ABC are all positive integers and A times B equals 156, B times C is 180, and C times A equals 195. Find the value of A plus B plus C. Okay, let's start with A times B equals 156. What are the factors of 156? It could be 4 times 39, or it could be 12 times 13. I think the correct pair is 12 times 13 because B times C is 12 times 15. I mean, 180 can be written as 12 times 15. Okay, and it looks like our A must be 13, so we can rewrite it as 13 times 12 so that our B becomes 12, and it looks like our C is 15, so 195 should be 15 times 13, which is correct. Okay, so we got the correct numbers. Our A is 13. 13 times 12 is 156. And then our B is 12. Our C is 15. Okay, let's check again. 13 times 12, 156. 12 times 15, 180. And 15 times 13 is 195. So our A plus B is equal to 13 plus 12 plus 15 or 40. Okay, so that is our answer. All right, for problem number 3, I already have my solution here. Split 2, 6, 8, 9, 11, 14, 15, and 17 into two groups of numbers, two groups of 4 numbers, such that the sums of the numbers in both groups are equal. Find the product of the numbers of the group that contains 17. So how are you going to split these numbers? The sum of each group should be equal. So you have to add all these numbers. If you add all these numbers, 2 plus 6 plus 8 plus 9, 11, 14, 15, and 17, the sum is 82. So if you split the sum into 2, or if you split these numbers into two groups, each group must have a sum of 41. Now make a group with 41 sum and another group with a sum of 41. So we can split the numbers into this group. First group is 2, 6, 8, 14, 11. That's equal to 41. And the remaining numbers are 9, 15, and 17. Their sum is also 41. So these are the correct groups. Now find the product of the numbers that contain 17. So the second group is the group that contains the number 17. So you multiply those numbers in that group. 9 times 15 times 17 is 2,295. This is our answer. 2,295. Okay, let's go to problem number 4. 18th of August 2018 is Saturday. Which date of the week will 18th of August 2030 be? Alright, to count the number of days, to answer this problem, we need to count the number of days first. From August 18, 2018 to August 18, 2030, which is 12 years. So that's 12 years. So 12 times 365 with the normal years with 365 days. But we have to add the leap year, the days for each leap year. So we need to determine how many leap years are there from year 2018 to year 2030. So the leap years start at 2000 and then multiples of 4 or every 4 years from year 2000. It means 2000, the first leap year after 2018 is 2020. So that's 2020 and then 2024, 2020, 2024, 2028. So that's 3 years. So every leap year has another extra day, so we will add those 3 extra days. So there will be 12 times 365 days plus 3 days, and that is equal to 4,380 3. So 4,380 plus 3 is 4,383 days. Okay, now to determine the day, we will simply divide this by 7. Each 7 days, or every 7 days, our day will return to Saturday, because we are starting here on a Saturday. So every 7 days it will be Saturday again. So we will divide this by 7. So that will be 4,383 divided by 7, and that is equal to 626 remainder 1. Okay, 4,383 divided by 7 is 626 remainder 1. And that remainder 1 means 1 day after Saturday. So our answer is Sunday. So August 18, 2030 will be Sunday. Okay, again, how did we get that? We counted the number of days from 18th August 2018 to 18th August 2030. That is 12 years, so 12 times 365 plus 3 days, because there are 3 leap years. The years 2016, 2020, 2024, and 2028. So plus 3 days. So that is a total of 4,383 days divided by 7. And then we get 626, remainder 1. If there is no remainder, it means the day must be Saturday. But there is a remainder 1, so that must be 1 day after Saturday or Sunday. Now let's go to number 5. Now the light is off. John presses the light button 2018 raised to the power of 2014 times. Can you guess whether the light is on or off? Okay, this kind of problem is quite easy. We just need to identify if 2018 raised to 2014 is an odd or even number. Since we have here an even base and an even exponent, we are certain that the answer of this number is an even number. And now let's have a trial and error. So now the light is off. After pressing 1 time, the light will be on. Pressing 2 times, the light will be off again. Pressing 3 times, the light will be on again. So the pattern is pressing odd number of times, the light will be on, but pressing even number of times, the light will be off. So the answer is the light will be off, because we are going to press the light button even number of times. Okay, so even number of times the light will be off. Now let's go to number 6. Peter goes west for 21 kilometers, then goes north for 13 kilometers, and goes east for 15 kilometers. How far is he from the original position? So this is a problem that applies Pythagorean theorem or Pythagoras theorem. So to answer this problem, we have to draw a sketch of our right triangle. So we start with a point, then from that point, Peter goes west 21 kilometers. Okay, so that will be 21 kilometers. And then he goes north for 13 kilometers. So this is 21, and then goes north for 13 kilometers. After that, Peter goes east for 15 kilometers. So this is our sketch. Again, from the starting point, 21 kilometers to the west, 13 kilometers to the north, and 15 kilometers to the east. So Peter now is here, and then we are going to draw a straight line from starting point to the end point. And we can see that we can draw here a right triangle. So we simply subtract 21 by 15. So this side here must be 6. So this is 6 kilometers. So we have a right triangle that looks like this. 6, 13. The question is, how far is Peter from his original position? So we are going to find this side, which is the hypotenuse of this right triangle. So that is the thing that we have to find, x. So to find x, that is equal to, okay, the square of that side is equal to the sum of squares of the other two sides. So 6 squared plus 13 squared. And we get 36 plus 169. And 36 plus 169 is 205. Therefore, x is equal to square root of 205. So this is our answer. Or that is approximately 14.32 kilometers. So Peter is 13.32 kilometers from his original position. Next, number 7. Now is 12 o'clock. How long does it take to let the minute hand and hour hand of the clock to overlap again? Alright, to solve this problem, we are going to use a formula wherein the angle formed by the hour hand and minute hand of the clock is always equal to 30h minus 5.5 m, where h is the hour value and m is the minute value. So when at 12 o'clock, our hour hand and minute hand are overlapping, so they form 0 degrees angle, and they will overlap again when the angle will become 0 again. So we're going to find the value of h and m here, where the angle will be 0 degrees again. And since we started at 12 o'clock, we believe that somewhere around 1 o'clock, the hour hand and minute hand will overlap again. So we let our h be 1, or the hour value is 1, and we have to find the minute value, or m. So we have an equation now. 0 equals 30 minus 5.5 m, and that is 5.5 m equals 30, or m equals 30 over 5.5. Wait, I'm sorry, I am mistaken here. After 12 o'clock, we are going to use the hour 13, not 1, okay? 1 p.m. will be 13. So the hour value must be 13. So this must be 30 times 13, which is equal to 360. Okay, 360 minus 5.5 m. So 0 equals 360 minus 5.5 m, or 5.5 m equals 360. Therefore, m equals 360 divided by 5.5 m. And we can rewrite that as 720 over 11. We multiply the numerator and the denominator by 2 to make the denominator a whole number, 11. And we can rewrite that in mixed number form, which is 65 and 5, 11. And then that is the number of minutes from 12 o'clock, which is equal to 1 hour and 5:11 minutes. Okay, so after 1 hour and 5:11 minutes, the hour hand and minute hand will overlap again, and that is the time exactly. Oh, the question here is how long. It's not asking what time, so this is our answer. After 1 hour, 5 and 5/11 minutes, the hour hand and minute hand will overlap again. Next, problem number 8. There are 16 problems. There are 16 problems in a mathematics competition. The scores of each problem are allocated in the following ways. 1 mark will be given for a correct answer. 0 mark will be given for a blank answer. 1 mark will be deducted for a wrong answer. Negative score is allowed. To ensure that 4 candidates will have the same scores, there should be at least S candidates in the competition. Find the value of S. To solve this problem, we just need to count the total number of possible scores. Okay, what are the possible scores for this mathematics competition? Since one correct answer is 1 mark or 1 point, so it is possible to get a score from 1, 2, 3 up to 16. And then, since 0 will be given for a blank answer, if ever one student leave all questions blank, so that student will get a 0. So 0 is also a possible score. And since 1 mark will be deducted for a wrong answer and negative score is allowed, if one student gets all the 16 problems wrong, her score will be negative 16. If she answered only 1 and then her answer is wrong also, she will get a score of negative 1. So scores from negative 1, negative 2 down to negative 16 are possible. So these are the numbers or the scores which are possible. 0 to 16 or negative 1 down to negative 16. And that is a total of 33. So 33 possible scores. There are 33 possible scores. Now, in order to ensure that 4 candidates will have the same score, we will add 3 more students. So that will be 33 plus 3 or 36. Because the other 3 students will always have a score equal to any of the 33 students. And we are sure that 4 candidates will have the same scores. Okay, so just count the number of possible scores and then add 3 more students. That's 4 minus 1. So the answer is 36. For problem 9 and 10 and 11, I already have the answers or solutions here. Let's read number 9. There are 2 green clothes, 7 white clothes, 4 red clothes, and 6 blue clothes. Find the minimum number of clothes to be taken randomly such that it is sure that at least 5 clothes have the same color. So we have 2 greens, 4 white, 4 red, for blue. Okay, find the minimum number of clothes so that at least 5 clothes have the same color. At least. Okay, so to solve this problem, we're going to eliminate the green, or we take all the green clothes, because it's not possible to make 5 green clothes. So we take that green, so that's 2G, and then we take 4 clothes for each other color. So we take 4 red, 4 white, 4 black, and then since we already took all the green, and then we took 4 red, now 4 white, 4 blue, we add one more cloth, and that cloth must have a color which is either red, either white, or either blue. If that is red, so we have 5 red. If that is white, we have 4 white. If that is a blue, we have 4 blue clothes. So we need to take 2 plus 4 plus 4 plus 4 plus 1, or 15 clothes. So the answer is 15. Number 10. There are 6 pieces of white chopsticks, 3 pieces of yellow chopsticks, and 4 pieces of brown chopsticks mixed together. Close your eyes. If you want to get a pair of white, yellow, and brown chopsticks, at least how many pieces of chopsticks are needed to be taken? Okay, so if you want to get a pair of white, yellow, and brown chopsticks, how many chopsticks at least must be taken? Okay, to solve this problem, we're going to get all the chopsticks with the most number of colors. So those are the white and the brown. So if we take all the white, so that's 6 white, and we take all the brown, that's 4 brown, and then we just need 2 more chopsticks. Since we already took all the white and all the brown, the other 2 will always be the yellow chopsticks. So our answer will be 12. That's 6 plus 4 plus 2. And the last problem on this page, factorize x squared minus 2xy plus y squared plus 4x minus 4. So how do we factor this one? Okay, so if we look at the first 3 terms, that is exactly x minus y quantity squared. Alright, because that is a perfect square trinomial. So, or perfect square binomial. So x squared minus 2xy plus y squared can be factored as x minus y times x minus y. And the other group, the last 3 terms, has a common factor of 4. So that will be 4 times well, we can try here 2 times something with x minus y, so that we will have a common factor of x minus y between the 2 groups, and then that will become 2 times x minus y, and then times 2 plus 2 squared. 4 is 2 squared. I wrote it in this way so that we will have something that looks like a squared plus 2ab plus b squared. Here our a is x minus y, and then our b is 2, and then here we have times 2 because of the 2ab. So here our final factor will be a plus b quantity squared. So the answer is x minus y plus 2 squared. Alright, so we are done with this page. I will end the video here. If you want more practice tests or problems, please subscribe to this channel. That is the only way that I will be encouraged to make more videos or tutorial videos for Hkimo or Hkimo exams. Okay, please like this video and please subscribe. Thank you.